Hello, everyone. My name is Al Season, and I'm the RTCA Vice President of Aviation Technology and Standards. RTCA is a standards development organization that was established in 1935 and has throughout its history provided the foundation for virtually every modern technical advance in aviation. Today, we kick off a series of webinars to highlight, discuss, and focus attention on the coming advancements in aviation and the technology that has helped the industry earn the enviable safety record it now enjoys. About this time each year, RTCA holds a two-day symposium. Given the current travel restrictions and to ensure the safety of our members and guests, we've decided to forego an in-person event and replace it with a series of webinars. Thank you for joining us today. We hope that you find this entertaining, enjoyable, and informative. And if so, we hope to see you at future broadcasts. We've invited some of the leading voices in the industry to join us online and provide you insight into their thoughts and plans, and later give you an opportunity to ask questions of some of our panelists yourself. Our speakers today are Terry McVenes, President and CEO of RTCA, Wayne Monteith, Associate Administrator of Commercial Space Transportation for the Federal Aviation Administration, and Gregg Leone, Vice President and Director of the Center for Advanced Aviation System Development, the MITRE Corporation. Included in today's webinar is also the announcement of RTCA's William E. Jackson Award winner. If you're having any issues hearing or seeing me, feel free to use the Q&A feature to send us a question, or you can dial into the webinar with your phone using the instructions sent to you by RTCA earlier this week. As I noted previously, we will have a Q&A chat with Wayne Monteith and Terry McVenes later in the program. Please use that same Q&A window to send us questions. This session is being recorded, and you'll be able to view it on the RTCA webinar channel by tomorrow. You'll notice the handout section on your screen. Please check those out. They're important materials supplied by our sponsors. At this time, I'd like to introduce the RTCA President, Terry McVenes. Terry joined RTCA in December of 2018. He brought with him his career experiences with Boeing Aircraft, the Airline Pilots Association, and as a captain with US Air. Terry, over to you.
Thanks, Al, for that kind introduction, and welcome to all of you, the participants, to our first in a series of webinars that we've titled Aviation Technology Connect, where we're going to convene, inspire, and evolve. As Al mentioned, we were originally going to schedule a live person-to-person symposium, but now we have this alternative means to convene via this platform where today and over the coming months, we're going to hear from a variety of aviation industry leaders on a broad spectrum of topics that we hope will educate you, further inspire you in your profession, and perhaps even evolve your thinking as to where the industry is today and where it's going in the future. Throughout the balance of this year and into next year, we're going to be convening on the third Wednesday of each month at this same time to continue with this program series. And each webinar is going to first focus on a primary topic, and then we're going to include a short, what we're calling tech talk from one of our industry leaders, who will share some of their insights with you that I know you'll find inspirational, strategic, or thought-provoking, with the primary goal of them giving you, the audience, a gift of their knowledge. We'll also be using this webinar series to acknowledge several of our special committee members from government and industry that have done outstanding work in the development of aviation performance standards throughout the year. I'm most grateful to our sponsors from the industry that have come forward to help us make this webinar series happen through the year. Without their assistance, this series would not be possible. And for today's event, I'm pleased to have Collins Aerospace, the National Business Aviation Association, NBAA, American Airlines, the Aircraft Owners and Pilots Association, AOPA, the MITRE Corporation, and the Airline Pilots Association International as sponsors for today's webinar. Without further ado, let's get started, and I can't think of a better lineup for this kickoff webinar than who we have on the agenda today, starting with our first speaker. For those of us that are old enough to remember the NASA moon launches back in the late 1960s and early 70s, I think we all had a bit of a tear in our eye when a couple of weeks ago we witnessed the NASA SpaceX launch of 2 Americans to the International Space Station, the first launch from US soil since 2011. I'm pleased to be joined today by Mr. Wayne Monteith, the FAA's Associate Administrator for Commercial Space Transportation. Mr. Monteith came to the FAA in January of 2019 following a 29-year career in the Air Force, retiring as a Brigadier General. No stranger to space launches, his last Air Force assignment was as the commander of the 45th Space Wing and director of the Eastern Range on the Space Coast of Florida. In these roles, he operated the world's busiest spaceport and has overseen the successful execution of 66 space launches, 23 booster landings, and the successful operational use of autonomous flight safety systems. Wayne, thanks for joining us today.
Thank you, Terry. Really appreciate it. I want to thank you and, quite frankly, everyone in RTCA for making this happen. I am very pleased to be able to talk just a little bit today about what we do in the Office of Commercial Space Transportation, give you a little bit of our history, our mission, some of our milestones that are coming up, and quite frankly, some of our challenges and where I see the industry going. And I need to do that to keep it informative, but quite frankly, also try to get you to understand the excitement of actually being a regulator. And having watched the Netflix series on Space Force now, I can tell you space is hard. So I want to get started right into this and take you back to the very beginning, 1957, and the beginning of the space race. And it was Sputnik on the left. And the United States got involved a year later, 1958, with the launch of Explorer 1. And so that's really where this all began. But as you can imagine, the first about 25 years of the United States space effort was all about government. The primary customers, the primary flyers, the developers, the designers, the recipients of the hardware were primarily the United States Air Force, NASA, and the National Reconnaissance Office. And that was really, for lack of a better term, the only game in town. And we made tremendous progress under that model. Well, in 1982, we had a company called Space Services Incorporated, of which one of the original employees was Deke Slayton, former Mercury astronaut, get involved and try to attempt the first commercial launch. And the launch was successful, although, as I recall, their payload was, I want to say it was 40 gallons of water. So it was really proof of concept. But they were also trying to determine how difficult or easy it would be to navigate government regulatory agencies to be able to actually get a commercial launch from start to finish. What they found anecdotally was it was harder to get authorization to launch than to design the rocket. Now, these are just some of the major government agencies that were involved at the time. There's actually 11 different agencies that they had to get permission from or authorization from to actually go through the launch. And there was no roadmap on how to go through this process or which organizations you had to talk to, which organizations were responsible for which aspects. And it proved to just be exceptionally burdensome to go through this process. And so in 1984, Congress got involved and actually granted my office statutory authority over commercial launches. We were originally located within the Department of Transportation. In 1995, we were moved from the Department of Transportation to the Federal Aviation Administration, which is where we've been ever since. But the regulatory environment on the commercial space launch industry or space transportation industry has continued to morph over the subsequent years. To include in 1998, we got reentry authority. Now, reentry authority isn't for, say, a Falcon 9, a SpaceX Falcon 9 booster returning to Earth in the first phases of flight, but it's a capsule returning to Earth. So think of a cargo capsule that goes, a commercial cargo capsule that goes to the International Space Station, or following this successful mission that Terry alluded to, where we successfully launched 2 astronauts for the first time since 2011 on a US-made rocket from US soil. When this mission is complete, subsequent missions, NASA crewed missions, will be licensed by the FAA or licensed by my office. In 2004 was the next iteration. In 2004, the most significant addition was the ability or the authorization to regulate the commercial human spaceflight industry. But interestingly, at the same time that we were given authorization, we're also put immediately or concurrently into what we call a learning period, or we refer to as a moratorium, where what we can actually regulate and the ability to promulgate regulations related to passenger or spaceflight participant safety was put in abeyance. Now that was because we did not want to, as a U.S. government or industry, want to preclude this industry from being able to grow. Now, since 2004, that moratorium has been extended 2 additional times. It's currently scheduled to expire in 2023, and I don't have any indication one way or the other whether it will expire or it will be extended once again. So since we cannot actually regulate many aspects of the spaceflight participant safety, what we do is we operate under an informed consent construct, where we, as the FAA, again, we protect the public. We will determine that the vehicle will operate in the environment it's supposed to operate in, and the spaceflight participants who are active participants in this endeavor will have to understand that it is there are dangers involved. So where does our authority come from? Unlike the rest of the FAA, which operates under U.S. Code 49, we function under Title 51. Our responsibility is to license commercial launch and reentry activities, and also launch and reentry sites, or what we commonly refer to as spaceports. I'm not going to talk about spaceports much in this presentation, so if you have questions later, that's great. Suffice it to say, we have 12 spaceports right now across the United States, of which 5 are actually accomplishing missions right now. But to get to the heart of what we're responsible for, it's ensuring the protection of the public, property, national security, and foreign interests of the United States. Where we significantly differ from Title 49 is we are also charged with encouraging, facilitating, and promoting the U.S. commercial space transportation industry. I can tell you we do, in my office, we spend a far greater time in this section on encouraging, facilitating, and we really don't do a whole lot of promoting. Today's commercial and space environment is far, far different than what we've seen in the past in that first 25 years where we had just purely government operations. These are just a few of the companies and the concepts that are operating today or functioning today. And this is just a few. What I don't have up here are companies like Relativity Space, Spin Launch, Astra, Virgin Orbit, just to name a few. But it's an exciting time to be in this industry because of the commercial influx. 20 years ago, nobody would have, or few people would have predicted what's going on in the industry right now. Particularly when you look at, NASA's commercial program. A complete game changer is we go forward unleashing American ingenuity and engineering. So with this influx on the commercial sector and the commercial space transportation, we're seeing a tremendous uptick in activity as well. What you don't see on this slide is 2012, we only had 3 licensed activities. We saw a little bit of slump in 15 and 16 and a steady growth. Now, if you look at 2020, we initially predicted a maximum, from our perspective, about 44 operations. And operations includes both launches and reentries. We think by the end of this calendar year, we'll probably hit 37, which is right in the ballpark of what we originally predicted. But you can see in the green bars, this is what industry projects, and industry could actually get there. But what we try to do is take what we've seen the last few years, where we think the industry is going, and because we use this as a manning tool as well to make sure the size of our office is correct. So what's driving all of this? There are a number of things. Number one is reusability. I talked about, you go back 10 years, 15 years, and nobody would have thought we'd have had this tremendous growth in the commercial sector. I can tell you, having been on Cape Canaveral when the first Falcon 9 booster flew back, very few people believed that flying a rocket back and reusing it was actually going to work. It's 180 feet tall. And not only do they land there, but they land on an autonomous drone ship, depending on the mission parameters, in the ocean. And that's like hitting a postage stamp. Tremendous innovation and, again, ingenuity that's fundamentally changing our industry. And we have other companies doing the same thing. Blue Origin is reusing their vehicle. United Launch Alliance, Vulcan is looking to be reusable. Rocket Lab is looking to catch expended stage ones under canopy. So we're seeing this throughout the industry. We're also seeing other pieces and parts, components being reused. SpaceX reuses their fairings, which is what encloses the payloads or the satellites. And they're also reusing their capsules. Again, 10, 15, 20 years ago, nobody would have predicted that. What this is doing is driving lower launch costs. We're seeing orders of magnitude less cost to get a kilogram to orbit than we saw just 15 years ago. And so what that does is it opens up the market. And when you add innovation to that, a company like Relativity, which is looking to do their entire rocket using additive manufacturing. Commercial human spaceflight, as I mentioned, future missions, NASA human spaceflight missions will be licensed by my office. But we also have companies actively going down this path right now, like Virgin Galactic. And then, of course, we've got satellite miniaturization. So think, from going from a satellite the size of a school bus down to CubeSats that are smaller than a bread box, which allows for greater proliferation, greater number of satellites on orbit, so therefore a greater need for launches. This was the first Falcon Heavy return to land. 2 Falcon 9 Stage 1 boosters successfully landed back at Cape Canaveral Air Force Station. Commercial human spaceflight. Now, I mentioned that while we are authorized, while we have the authority under Title 51 to regulate the safety of this industry, we're under a learning period or a moratorium. But what we have done is developed recommended practices or best practices that will allow the industry to know what we're thinking. And these best practices and standards were developed with industry. I think it's a 62-page document, about 100 recommendations that will also lay the foundation for when we do, when the moratorium is lifted at some point in the future. And we continue to work with organizations like ASTM to develop standards, again, as we look to 2023 and beyond, whenever the moratorium is lifted, because the future is here. We have companies flying today. We have companies actively looking to fly more, space flight participants. And at some point, much like the aviation industry, there's going to be an inflection. There's going to be a time when you have enough flights, enough spaceflight participants that they become passengers at some point. And therefore, it would make sense to have a stable regulatory environment, not only for passenger safety, but also for the companies and any investors that are involved in those companies. But it's also about the excitement that's generated by these types of endeavors that is also driving our industry forward. This is Virgin Galactic's second crewed flight. I actually was given the honor of presenting commercial astronaut wings to this team. In the upper left and actually in the lower left as well is Beth Moses. Beth has the unique distinction of being the first individual to actually unbuckle in suborbital flight, is the first non-pilot crew member to fly suborbital, and is the first woman awarded commercial astronaut wings. So kind of hit the trifecta. Our numbers or our wings are currently individually numbered, and appropriately she received wings 007 to mark the occasion. But we are at an inflection point. I see launch rates continuing. When I was at Cape Canaveral, our 30-year average for launching was about every 6 weeks or so. As I departed, we were launching every other week on average, sometimes multiple times during a week, looking towards being able to effectively launch every single week. And my successor, Brigadier General Doug Shess, is leading that wing to launch essentially on demand. And we're seeing this. We're seeing multiple launches, potentially in a single day. Certainly, it's coming far more common for multiple launches in a week. And what's driving that? Well, if you go back to my opening slide with Sputnik in 1957, since that time, about 8,700 or so satellites have actually been put in the orbit by spacefaring nations around the world. And of those, there are about 2,800 of those are active. About 5,000 are still on orbit. The other 3,500 have re-entered. But about 2,800 active satellites on orbit today. If you take out the SpaceX Starlink constellation, it's about 2,300 satellites on orbit by the rest of the world. This number on orbit could increase fourfold over the next few years. You know, in 2013, when we did a forecast of what was coming up in this time frame, we looked at somewhere on the order of about 30 launches a year, which we've hit, but about 50 to 55 satellites being launched a year. I can tell you last week, we launched 61. A single, and that was on SpaceX and Rocket Lab. A single SpaceX Starlink mission launches 60 at a time. So if you go back to that original top line, 2,800 satellites, we're growing at a tremendous rate. And it's not just SpaceX. OneWeb, I know, are having financial issues right now, but they put up 68 satellites on their way to 648. Amazon is looking to put up 3,300. Starlink will probably is programmed to get to about 12,000, and I believe they now have authorization for another 30,000. So if you go ahead and look at the numbers again, and you dissect it out a little bit, by the end of 2022, you potentially could have more Starlink satellites on orbit, active satellites, than the rest of the world combined. And within 7 or 8 years, SpaceX may have launched more satellites into orbit than the rest of the world since Sputnik. That's driving this industry. Now, when you throw on top of that the commercial human spaceflight, and you look at Virgin Galactic's plans, they're looking to fly multiple hundred times a year, taking passengers in or spaceflight participants into suborbital space. So how do the regulators keep up? Well, first off, you've got to have a safety organization that's built for not just effectiveness, but scalability. By scalability, I mean, 2012, I told you we had 3 launches. At the time, that was about 25 employees per launch. At the rate we're looking now, we're having maybe 2 people per launch, going to less than a single person for a launch or a licensed launch. which means you better be effective. You better be able to scale your organization. Every single internal process has to be designed for efficiency. You have to have enough of the right people with the right skills to regulate this industry. So it's not just a numbers game. It's also us competing with private companies and other government agencies for these highly sought after individuals. You have to have an organization that's internally and externally accountable. And then you have to have that built on a foundation of a regulatory construct that is designed to allow for that innovation and has enough flexibility for companies to be successful, to go fast, and to try new ideas. So reorganization, I joined the office in January of last year, and the Secretary of Transportation, Secretary Chow, charged me with reorganizing my office to get to some of this. I can tell you about 7 weeks ago or so, we completed our reorganization. We have already seen increases in effectiveness and efficiency because we've organized functionally and we have single individuals accountable for entire processes. In the way we are set up, we can absolutely scale the organization. And by doing it efficiently, we don't have to have 4, 5, 100% increase in number of employees to handle the 4 or 500% increase in workload. I talked about a foundation of regulations that will allow this industry to be successful, to go fast, to be able to innovate, to be able to continue to lead the global market in this transportation sector. Space Policy Directive 2 mandated to us that we would come up with a new regulatory construct that was performance-based and not prescriptive. A lot of my regulations today tell you exactly how we expect you to operate. And as great and innovative as my team is, if I've got 50 engineers, it's hard to compare with a company with 1,000 engineers for great new ideas. So I can say that we've done that. So we put out last year a notice of proposed rulemaking. It's got a safety foundation. We'll never walk away, particularly as part of the FAA, never walk away from our core safety mission, a safety mission driven by data. But what it does is it combines all my regulatory parts, my 4 major regulatory parts for launch and reentry, both from an expendable perspective and a reusable vehicle perspective. So what this does is it puts under one regulation, essentially, the ability to regulate everything that will launch to space or suborbital space on every different kind of vehicle to any duration, any type. So it really gets us from a launch regulatory construct much more one-stop shop. But it also allows companies to have a single license for multiple launches at multiple locations, which really gets or knocks down many of those bureaucratic impediments to industry success. And then finally, as part of our mandate, and we've taken this into this new rule, and I take this seriously, is only regulating to the extent necessary and no more. But it's tough. Nobody, in their souls, nobody really likes to be regulated, but it's necessary. You want your food safe, you want your highway safe, you want your skies safe, but regulating only to the extent necessary. Nobody likes stop signs until you come up to a clear 4-way intersection and nobody knows who's going to stop and who's not. Nobody likes speed limit signs until somebody's driving dangerously around you. So our job is to find that right balance between safety and allowing industry to innovate and go fast. And I can tell you, as the stage we are in the rulemaking, which is finalizing it right now, this is when the miracle happens. And I personally, as is the FAA Administrator, Steve Dixon, we are reading every single word in the preamble and in the regulation, which is probably all combined somewhere close to 800 pages, every single word to make sure that it makes sense. And not only does it protect the public, but it holds to that mandate of regulating only to the extent necessary and will allow U.S. industry to be successful. So once you get that done, now you've actually got to launch and you've got to get to orbit. Now on the left is a typical screenshot for what you would see in the National Airspace System on a typical day, and all those dots are air traffic. We've got to get through that traffic to get to space. Currently, what we use is a construct called segregation. Now, we segregate huge swaths of airspace, which is, from a safety perspective, is great. From a business perspective, aviation perspective, it's not so great. While in total, we represent a small part of the disruptions to the NAS, there is always a potential for a safety mishap. The issue that we have is the way we are currently operating with the technology that we have. When we realize, from the time that we realize that a rocket launch has experienced a catastrophic anomaly, to the information is in the flight deck and a crew can take some action, can be anywhere from 14 to 18 minutes, because we use voice commands, we use sneakernet, we have air gaps between systems, there's hand jamming information back and forth. So you've got to segregate a wide swath of airspace. We've been working on a prototype called the Space Data Integrator that was under the responsibility of my office to try to fix that or help alleviate that. At the end of last year, I asked that responsibility be transitioned to our Chief Operating Officer, Terry Bristol, and her phenomenal team in the Air Traffic Organization, because they control the requirements, the priority, the funding to make this work. And I am absolutely confident now that we're going to field something that will allow us to move from a segregated airspace to an integrated airspace that will significantly reduce that time. It also helps on the space side, because a single general aviation aircraft violating restricted airspace in a rocket launch can actually, so a single Cessna 150, for instance, with a single passenger or single individual on board can stop $1 billion launch. And so that's not effective either. On the lower right is what we've got to get into. Now, you hear about space debris, space traffic management. There's a lot of debris up there. A lot of it's small, but when it's traveling at 18,000 miles an hour, Einstein's E equals MC squared comes into play, and you can destroy another vehicle, another payload. We've got to get through that. Now, this depiction here is just a depiction. It's not what it actually looks like. If you were to take and look at this from an actual perspective, you wouldn't see a single satellite. So each one of these would have to be 2 to 3 kilometers in size for it to show up like this. But what it does demonstrate, when you interleave this with what I talked about earlier and where we're going with the number of satellites on orbit, it starts making our job difficult. My job is not to manage the traffic in space. My job is to get you onto that highway. And so think of it like the Beltway in Washington, D.C. We are an on-ramp. And so we will make sure that you are, to the extent that we can, safe through your first approximately 3 hours of your launch mission or your mission. That means I've got to get you on an on-ramp that gets you onto this highway. And if I can't successfully do that, then you can't get onto the highway, you can't conduct your business. As we have more and more satellites in orbit, we've got to be more and more concerned with that. So bad things do happen. I've been around for all 4 of these mishaps. And these are all recent. If you look at the bottom right, that is actually an exquisite communications satellite within a payload fairing. That was AMOS 6. We went from everything was great and normal to everything was gone in a few milliseconds. But the company learned from that. We learned from that. Each mishap, each catastrophic anomaly that we go through, we learn from, and the industry is better. Some of this occurs during testing. It's exactly why we test. But the most important thing to take away from this is nobody was injured. Nobody was injured. So in the history that we've been doing this, we've had no injuries, no fatalities. So that's what we want to continue doing. And wrapping up, all I want to say is the future is bright. We've got new innovation, new concepts. We've got tremendous excitement and growth in this industry. I've been in this business for 30 years, and I have never seen this kind of excitement and this kind of focus all the way from the White House through Congress, through the departments, all the way down to the American people. We're launching U.S. astronauts from U.S. soil again. And as great as it is to see them launch from other places in the world, there's nothing like seeing it from the Space Coast in Brevard County in Florida. Just nothing at all like that. And it's an exciting time. And with that, that's what I've had prepared for you today. Thank you very much for your time. And Terry, I look forward to the rest of our discussion.
Much, Wayne. That's you say the future is bright. I think I would add that the future really is now. I mean, it's here, and you're definitely living it. I'd like to start off with a few questions and just to kind of get things rolling. You did a really nice job explaining kind of the history of the FAA's office there for commercial space. Was there any maybe one or two or three driving factors that kind of led the FAA to go down this path of developing their own office for commercial space transportation?
Yeah, you know, as I went back through this, and quite frankly, I had a discussion with Secretary Chow on this in one of the first meetings, and I got to tell you, she is a huge proponent of space, and is interested, which is great to see. When your leadership is excited about space as you are, it's amazing how easy it is to move mountains. But she was around during that time, and it really did have to do with space systems and Conestoga 1, and the uncertainty and the effort that it took to actually get a U.S. commercial launch. You know, anecdotally, when I was reading about how our office got started, one of those symbols that were up on there was Bureau of was ATF, alcohol, tobacco, and firearms. They actually had to get a federal firearms dealer's license to be able to accept an old ICBM first stage because they thought they were originally going to go with a solid rocket motor. And so they had to get a firearms license. Who would think of that? And then they couldn't actually buy one. So they went to NASA and asked NASA if they could provide one. And NASA apparently said, well, we can't sell you one, but we'll lease you one at full cost. And you'll get your money back if you bring it back to us. But as expected, it ended up in the bottom of the ocean. So that really drove this. Now, like I said, we started off in 1984 in the Department of Transportation. And I think back in 1995, when we were moved to the FAA, there was a clear understanding of the synergies involved with my office, air traffic organization, Terry Bristol's office, quite frankly, Kirk Schaefer's office, airports, and Ali Barami in safety. And so there are tremendous synergies between our organizations. And as a matter of fact, I was on a phone call one-on-one with Terry just this morning. We catch up at least once, a couple of times a month, as I do with Kirk and Ali, on figuring out how we can do all this better, particularly that integration into the NAS.
Yeah, and are you interacting with some of the other offices like flight standards and certification, either from lessons learned from their experience, or how is that working internally with the FAA?
Well, interestingly, so part of my reorganization, I've brought in a couple of new executives, so SES level individuals, and quite frankly, my coup was to be able to get a member of the FAA. Her name's Leone Liu, who actually started off in aircraft certification and was most recently Ali's deputy and ran the Office of Rulemaking. So the rulemaking aspect, as we're in the middle of all this streamlined launch and reentry regulation, it was a benefit to get her on board. But she brings with her a wealth of experience as we work to become more like the FAA. I joked a little bit about Netflix and Space Force, and space is hard. Throughout my career in space, I've also heard that space is different. And so therefore, we should be doing things differently, and we should perform differently. We don't. We should be like the FAA. We should be integrated. And so we're trying to bring those lessons learned in and see what we can do. And I don't want to recreate the wheel. And we've even talked about, maybe there's a point where on the commercial human space flight, you get to a point where a certification type program makes more sense than an individual license. So we're looking at everything with an eye towards how do we enable and empower this industry while still maintaining public safety.
Yeah. What about externally? How does your office collaborate with maybe some other government organizations or industry itself, like NASA, MITRE, and some of the actual industry participants in the commercial space?
So I can tell you, particularly on the interagency side, intergovernmental, hand in glove. We meet regularly at my level down to the working group level, using what we call a common standards working group. And on that group sits my office, NASA, the National Reconnaissance Office, the Office of the Secretary of Defense, and the Air Force and Space Force, as we talk through standards. Because what we don't want to do is create an environment where if you're a launch provider, a rocket owner, operator, you don't want to have a different set of rules and regulations that you've got to meet, depending on where you fly from. And we saw this when I was running the Eastern Range. SpaceX has two launch complexes out there, 39 Alpha, which they do their human space flight from, 3 miles south, and 39 Alpha is on Kennedy Space Center. 3 miles south, Launch Complex 40 is on Cape Canaveral. From a safety perspective, when I showed up in 2015, if you moved between those launches, you had to redo your safety work. They were 3 miles different. It was an imaginary line on a map. So we work closely with them. NASA, of course, we're working real closely with as we transition licensing for the human spaceflight part for them. We also have a long working relationship with companies like MITRE, a tremendous partnership, aerospace. And so we do a lot of industry outreach. I meet personally with COOs and CEOs of our stakeholder companies. I go out on site at the vice president level. Leone meets with those, and we work together to figure out where the friction points are between our teams. At the lower levels, our teams are all working to try to make a difference, but sometimes you don't always see eye to eye. And rather than exchanging a couple hundred emails, it's amazing what happens when the two bosses talk.
Exactly. You mentioned there are now 12 spaceports that have been identified, 5 of which are operational. Maybe this is a two-part question. I'll ask the first part first. What's the maybe the range of capabilities across the 12, and what are their plans kind of for the future? And the timelines for it?
So interestingly, the spaceports are regulated under what we call Part 420 of our regulations. We have some spaceports that are standalone. Quite frankly, some, like the shuttle landing facility, is essentially a runway. It's where Space Shuttle used to land. We have some that are set up for vertical capability, some for horizontal and horizontal only. So let's say Colorado Air and Spaceport. Because they're located in Colorado and where they're located, which is near a major metropolitan area, and quite frankly, Denver International, I would not envision in my lifetime a vertical launch capability. So vertical launch, think Saturn V or SpaceX. Horizontal launch capability, think captive carry like Virgin Galactic does, where you have a carrier aircraft, White Knight 2 in this case, or potentially Virgin Orbit, which has a rocket that hangs off the wing of a 747. You would take off like any other aircraft. And then, so you would sequence into the air traffic pattern, you'd fly off to another location and drop your payload, and your payload would go to orbit. And then we've got some that it's not clear the path that they're on. So like I said, we have, I believe 7 right now that aren't active. That doesn't mean they won't be active. But the way we look at it on the licensing part, because it takes a significant amount of time to actually obtain a spaceport site operator's license or launch site operator's license. You start that early. You start that before you have an actual customer, which is different than airports. And that's because it's still a nascent industry. So when you throw in the environmental timelines, you're really talking years. So if you have a launch customer comes in and says, hey, I want to launch, but it's going to take you 5 years to get an operator's license to open a spaceport, the launch operator is going to be long gone. Yeah. So right now we also have, so those are 12 licensed spaceports. We have, I want to say, 7 other spaceport candidates that we are currently working with.
Very good. Just a couple more, and I think there's a few from the audience too, but I know there's a few industry associations here in DC, and perhaps some others outside of the Beltway, and I think some of them are even part of our audience today that have expressed concerns over plans for commercial space operations. What do you say to them?
Trust me. What I say to them is, I'm an operator. That's my background. I spent 29 years in the Air Force as an operator. I did other things, but at the core, I am an operator. And I believe that's one of the reasons why I was fortunate enough to be able to join the FAA. I understand the problem. And so if you look at strictly numbers, and so let's go back to the aviation example. When you look at it, and this is data from, I believe it's the first half, the first 9 months of 2018 was the last time I looked at the data. If you look at all of this disruptions to the NAS, either by additional miles flown by aviation, by aircraft, or passengers delayed getting to their destinations, depending on how you do the statistics and slice it, space launches, commercial space launches, represent somewhere between about 0.04% and 0.07%. So it's not great, but it's an issue. For me, I look at it from a safety perspective. The absolute worst thing that can happen is that we cause or we allow an aircraft to be damaged or destroyed because of a rocket catastrophic failure. And so first and foremost, this is based on safety, so I understand that. Secondly, that is why ATO and my organization are working hand in glove on solving this problem before we get to the right side of that chart where I told you there are multiple hundreds of launches a year. You know, at 30 launches a year, it's irritating. At 300 launches a year, it's impacting business and has the potential for safety. So we are working diligently on that. And on the other half, you know, the space transportation industry, again, they want to be able to launch. So we have 2 periods a year at Thanksgiving and at the Christmas holidays where we have HARP, which is an airspace restriction, where you don't launch rockets because of the amount of air traffic on the eastern seaboard. That impacts business. You know, imagine if it was on the aviation side and we said for 2.5, 3 weeks out of the year, you just can't fly. That disadvantages U.S. industry. And so we need to work together, and that's why we're working towards integration.
And one question, and then we'll turn it over to the audience, but you mentioned this briefly in terms of the importance of having technically qualified individuals that are part of your workforce, and that always is a challenge. How's the FAA doing with attracting not only qualified people, but people are really enthusiastic to work in this area?
Like I opened with up front, it's my job is to make being a regulator exciting. And I think we're doing that because we're at a confluence for all of these great things that are going on in these great companies. And so one of the things that we do, number one, we're reaching out far and wide. But number two, I talked to them a little bit about my story and how I ended up at the FAA. When I retired from the Air Force in December of 2018, I had 3 primary goals. Number one, I wasn't coming back to government. I'd done about 30 years. Number two, I wasn't moving back to Washington, D.C. Not that I didn't love it, but I wanted to do something different. And number 3, I wasn't going to work in 2019. Well, I violated all 3 of those. I joined the FAA. I moved back into my home in Washington, D.C., and I managed to stay retired for a full 6 weeks. And why did I do that? I did it for this job. This job, you were at everything that's going on in the industry. And so for this year, we've got 5 fresh outs joining us. We'll be freshly graduating from colleges in the country. I think our first 3 are from the Ohio State University. I don't want to get slammed, but we're bringing them right out of college, teaching them how the regulatory construct works. In a perfect world for me, they'll work with me for 2 to 5 years, and then they will go into industry, and we'll have this flow back and forth. So bottom line is, I'm not having trouble recruiting right now, either brand new engineers or experienced engineers, because of what's going on and the ability to make a difference.
Well, certainly an exciting field that I'm sure is attracting a lot of great people. Al, understand we have a couple of questions from the audience.
Yeah, we have a question. With space debris of all sizes and energy states to which you previously referred, how are we managing the potential of inadvertent collisions that may result in unintentional re-entry of debris and invasion into the NAS? And how do we keep the communication times of these events small?
So great question. First, on most of the debris that would potentially re-enter coming from low Earth orbit, most will burn up long before it re-enters our atmosphere or gets down where it can damage an aircraft. We're far more concerned with a rocket launch that's already within the atmosphere, has a catastrophic anomaly, and then you've got debris raining down. With that said, though, I can tell you space traffic management, or managing what's up there, keeps me awake at night. There was a NASA scientist, Donald Kessler, who developed a theory called the Kessler syndrome or the Kessler effect. And that's in low Earth orbit, once things start colliding, you have at minimum a geometric, maybe an exponential growth in the amount of debris, which creates more debris. I saw this in my Air Force career when Cosmos 2251 and Iridium 33 collided, and you went from 2 targets to hundreds of targets and created a debris cloud. We've got to do something about that. Space Policy Directive 3 that was put into place identified the Department of Commerce as being responsible for space traffic management. So we've got to manage space from a safety foundation. We've just got to. When I talked about the number of satellites that are going up, you're talking potentially 1,500 satellites a year. This problem will get unmanageable way too quickly. So we've got to get ahead of this.
Is there another one now?
Yep. Another question. Do you see any specific near-term FAA, ATO, NAS procedural changes that will help move more quickly toward an integrated airspace?
I do. And, that was one of the reasons why I transitioned responsibility for the Space Data Integrator, or asked for it to be transferred to Terry Bristol, which she absolutely accepted. She understood what we were trying to do. And we still provide technical expertise in liaison to our industry, but they're doing things like time-based operations. So what they're doing is they are shrinking the airspace and the notification times that are required. So, you look at some of the disruption caused by a Falcon Heavy operation, and there were times both at the front end and the back end of the restricted airspace that weren't really, that it turns out we didn't really require. So we are laser focused on that. We're looking at, are there logical points in the countdown where we know we're going to go, or we know we're not going to go. So if our countdown window is 6 hours long, but we know the launch company won't use the first 3 hours, we don't need to clear the airspace for 3 additional hours. We know that when we get to a trigger point, a certain point of fueling or weather, that there's a good chance we can go. Now we can start diverting aircraft. So yes, while we wait for a technical solution, Terry Bristol and her team are absolutely working on operational changes that can be implemented now to help solve this problem. And as you well know, our FAA ATO are the best operators in the world for running an airspace. there are none better. And so they'll fix this.
Great. Any more, Al?
Yeah, there's one last one. Due to the nature of commercial spacecraft launches and recovery, the portion and time frame of airspace restrictions, if not reassessed, will become disproportionate in the way they affect commercial aviation and other airspace users. Do you believe we are in a position to bring this discussion to ICAO in order to seek for global harmonization?
It's probably a little out of my wheelhouse to answer all of that. What I can say is I have been in discussions with many of our international partners on airspace and how we effectively integrate commercial space and commercial aviation, and they're looking to us. We've connected some of the other space agencies with Terry's organization as well now, so we can work together on this. But I think they are looking for us to lead this effort because, quite frankly, we've got the highest aviation traffic. We've got the highest commercial space traffic. You know, we lead the world in number of commercial space launches. So it's really I believe it's incumbent upon us to lead the way and to develop that foundation that the rest of the world can use, so we don't have to create all of these different constructs.
Well, I think that's a good place to end this section of our webinar. Wayne, thank you so much. After you and I spoke a few weeks ago, everybody I talked to, I told them how great this was going to be hearing from you, because you bring such passion and energy, not only to your role, but to the whole topic. And to that end, you sure didn't disappoint. And I'm sure the audience enjoyed it as much as I did. So thank you again, Wayne. Appreciate it.
And Terry, I just want to say once again, thanks so much to you and your organization, to everybody at RTCA that helped make this a success. I just can't thank you enough for helping us get the word out and to be able to continue to collaborate with your organization, organizations just like yours. So again, thank you very much.
Our pleasure. Thanks. Well, each year RTCA presents a scholarship award to an outstanding graduate student in the field of aviation, electronics, and telecommunications. And this scholarship, which we first started in 1975, is named in honor of William E. Jackson. And he was a true pioneer in the development and the implementation of this nation's air traffic control system. He was also a very enthusiastic supporter of student engineers, and his deep interest in engineering students became an inspiration for many of those choosing a career in aviation. An interesting side note about Mr. Jackson, back in the mid-1920s, while he was working for General Electric, he was a part of a centralized group of thousands of experimenting wireless engineers around the world, referred to as hams. Some of us have heard that term before. And they used ham radios and Morse code to communicate among themselves between 42 different countries. It was all part of an effort to improve code transmission when two-way communications was the first wireless technology. Well, this year I'm really excited to present the 2020 William E. Jackson Award to now Professor Tyler Reed. Dr. Reed's submission to the award selection committee was a dissertation that he wrote while working on his Doctor of Philosophy degree at Stanford University. It's entitled Orbital Diversity for Global Navigation Satellite Systems, or GNSS. And the underlying theme of his dissertation is that by utilizing new orbit representations, improvements can be made to the service, reliability, and the functionality of GNSS. Before I turn things over to Dr. Reed for a few comments, I have to say that his dissertation was not only a technical masterpiece, but in his acknowledgments that he wrote, it was clear that his family and his friends, teachers, and professors have played a monumental role in his interest and drive for space exploration. So Dr. Reed, congratulations on being selected to this year's recipient of the RTCA William E. Jackson Award. Dr. Reed?
Thank you, Mr. McVenes, for the kind introduction. I'm deeply honored and humbled to have been considered for the RTCA Jackson Award, and it's a great pleasure to be here with you today. In accepting this award, I would like to express my gratitude to the RTCA and to the award committee, especially for making accommodations for this virtual award ceremony in these very interesting times we find ourselves in. And of course, I must also thank all those who supported me in making my dissertation possible, including my mentors, colleagues, friends, and family. In particular, my PhD advisors, Professor Todd Walter and Professor Paranga of Stanford University. Todd, your continued guidance still orients me today, and your friendship is something I look forward to as we continue to work together on projects both past and future. And Per, I am honored to have had the pleasure of working with you. Your passing was a huge loss to us all in the navigation community, and we miss you. And so, Per, I dedicate this award to you. Your enthusiasm for teaching and your commitment to your students is something I will always remember. To my friends and colleagues, I made lifelong friendships during my time at Stanford. The energy, creativity, and work ethic in the hallways of the Aero-Astro building is unmatched in my experience, and it was a very special time in my life. Looking forward, I'm happy to report that several of us from those same hallways have now banded together to form a startup working in commercial space, where I can see these same traditions already emerging and continuing in our culture, and I'm excited to see where we go from here. Most importantly, I would like to thank my family, in particular my mom, brother, grandmother, and wife, Sarah, whose love and support have made my journey through grad school possible. And finally, a big thanks to all of you here today for being here to support in this award. So thank you so much, and back over to you, Terry.
Well, thanks, Dr. Tyler. Again, congratulations. This has become one of my most favorite things to do as president of RTCA, because it's a chance to really showcase the future leaders in aviation. And you're a great example of what the future has to hold for us in this great field. And by the way, we will make sure that a real check and a commemorative plaque gets sent to you in short order. So thank you.
Thank you.
Again, I want to take just a moment to thank all of our sponsors again for today's events. Even during these difficult times, these organizations have been gracious enough to make today's webinar happen. And so again, thank you to Collins Aerospace, MBAA, American Airlines, AOPA, the MITRE Corporation, and the Airline Pilots Association. Your continued support to the industry and to RTCA is very much appreciated. So to conclude today's webinar, it gives me great pleasure to introduce Mr. Gregg Leone. He's the Vice President and Director of the Center for Advanced Aviation System Development at the MITRE Corporation. In his role, Gregg leads MITRE's overall domestic and international civil aviation, aerospace, transportation strategy, and business operations. Now, Gregg is no stranger to RTCA and our members, having served on our advisory board for a number of years now. So when Gregg speaks, it's going to be very insightful and thought-provoking. So Gregg, over to you.
Great, thanks, Terry. And first, let me congratulate Dr. Reed. What a great award and great accomplishment for you. Thanks, Terry and RTCA, for putting this on and giving me an opportunity to speak to you all today. A quick word about MITRE, because I always like to not assume that people know who we are, because we're a little bit different kind of a company. First, let me just say MITRE is it's a fairly large, not-for-profit private company, about 8,000 plus people. We're in the business of running federally funded research and development centers, and MITRE does that across the government. We have a whole of government perspective, and why some of the things that I'm going to talk today, especially when we're going to be talking about this whole notion of surface to space operations, why it's so important. And FFRDCs are put in place for our government sponsors to basically deal with big, hard, thorny problems. Okay, not things that you can just buy off the shelf, but really things that require critical thinking. This whole notion of transferring all the new entrants, commercial space in the future is one of these huge, big, thorny problems. And I really want to focus on how do we accelerate innovation to this future. Now, when I talk about future, I'm talking about 15 years from now. And I want to start maybe by, I was talking to a friend of mine earlier this week who's been in the industry for a long time. And he reminded me, he said, Gregg, he said, I was involved in the early days during the Petco strike in the early 80s. I've been around since 9/11. I've been there through the financial crisis and fuel crisis and SARS, and I'm in here today. And in the beginning, I thought, wow, can this industry ever recover? And in the bottom line is every single time we do recover, planes will continue to fly. And we don't just recover, we recover stronger than where we were from whatever the problem was. And I say that because it's important not to worry about the problems. Actually, big problems typically create big innovations. And, I think about this whole notion of the pandemic, COVID-19, the things that we're going through today. Who would have ever believed that we could transition all of our mission activities through a virtual environment and still contribute without missing a beat? Planes are still flying, okay? And think primarily how we did it. We did it by pivoting to commercial platforms, okay, to do these kinds of things. We didn't know we were going to do that. We weren't set up, most of us, to do this level of virtualization. So again, another important point, our pivot to commercial solutions. So I want to kind of set up this notion of the future. Okay, what is the aerospace system of the future? And this notion that we really got to change our thinking about the structured national airspace system the way it is today. I think about the terms that we use that kind of bound our thinking. And I think of simple terms like IFR and VFR, instrument flight rules or visual flight rules. I mean, these things we say this every day. It is something that is critically important to the safe operation of the national airspace system. But the majority of the new vehicles that are coming into our national airspace system, they have no flight decks. There are no pilots in the cockpit. They're highly or totally automated. Okay, and so this whole notion of the future and how do you build to support the future, we have to kind of unlock ourselves from the boxes that we're in today. The other thing we think about and talk about is this whole notion that our airspace has been somewhat segmented, and we think about maybe drones at low altitude, commercial space in the middle, a commercial or civil aviation in the middle, and above 60,000 feet, some other kind of operations. Those are great constructs for providing safe operations, but in the future, we really need to move to this notion of an integrated set of operations across the national airspace system. The other thing I think about is, how do you do that? And it's this notion of moving from today, a command and control environment where you have a great air traffic controller providing separation services to a set of aircraft. And you're basically watching, monitoring, and moving those aircraft across the national airspace system. It works spectacularly. And that's why we set up command and control capabilities. Sorry about that. I'm getting a message that says my microphone is off. Can people hear me? Okay, I'll assume it is, and I'll keep on going. It's okay, Terry?
Yeah, it's coming through fine.
Okay, thank you. I just wanted to, back to this whole notion of command and control. It works great for today, and it'll continue to be great in the future. But to kind of scale the way we need to scale in the future with all these new entrants, we need to think about this whole notion of a tightly connected, integrated, and empowered set of operations that allow the new entrants to basically maneuver, to work with a whole host of different service providers to provide operations and capabilities that they need for the future. So this flip from command and control to a massively integrated system that work together is a little bit of what I want to talk about, and is what the future will enable our future operations. And by the way, this is a big, complex problem. Okay, this isn't something that we're going to do overnight. And I want to kind of address it in three areas: in operations, in infrastructure, and of course we have to talk about safety assurance. And so think 15-ish years from now, the characteristics of what this national airspace system will look like. Services that will be provided by a whole host of different service providers. It will be a diverse set of operations, much more diverse than we have it today. And it'll be new vehicles, new missions, new operations, all of them having different kinds of performance capabilities. And we'll need to enable this new operation of integrated tailor management of these systems through a set of new information exchange that don't exist today. And when I talk about next generation of information exchange, number one, I want to talk about, think fully connected, think Internet of Things, think highly resilient. The other thing is think commercial. Think commercial infrastructure. And I go back to just over the last several weeks, the SpaceX flights, we just heard Wayne talk about hundreds and hundreds of satellites, thousands in the near future from SpaceX that will provide highly resilient broadband global internet services at a low cost. And they're not the only ones that are going to be doing this. So we'll have a completely different set of technologies globally to provide high-speed broadband internet. That is going to help us do a whole host of different things. And kind of simply to kind of change your mindset, I think of, we all have these phones, and in this new environment of a highly connected environment with global broadband anywhere you are in the world, I think of the possibilities of today, a pilot turning on their Find My Friends or Share My Location on this phone with their AOC, their Airlines Ops Center, or with neighboring aircraft. You instantly have secure information back and forth to the ground through broadband. I'm not suggesting that the iPhone is the answer. I'm suggesting the possibilities are going to be endless with the technologies that are there. These are not dreams. These are realities that are coming. So we got to figure out how to leverage it. The other thing, you get with these kind of ubiquitous information flow all over the place is this notion of a nowcast environment. This notion that you're sharing weather data, flight data, flow data, aeronautical data, anything that is needed for you to operate. Those are things that you'll know how to connect into, you'll know how to manage your operations with, and you'll know how to do it safely. And so the thinking is, how do we enable those things? And how do we set the standards for that information sharing going forward? The other thing is, I think once we get to this place where you have this ubiquitous information sharing, this nowcast of everything, new entrants, new business models will flourish. Okay, they'll know how to push and pull data. They'll know how to operate in a manner safely. They'll know how to participate fully. And everybody will have a responsibility to participate fully, push, pull information that's needed to ensure their safe operations and others as we go forward. The other thing, this will be done in a totally public-private infrastructure instead of services. I think about the bottom line, maybe the point that I'm making is this is not going to be a big government solution. All right, clearly we all are in this together, basically. We all have to work together. Let's talk safety assurance in the future of this environment. And again, technology is already there today to safely pull things out of the flight management system into a tablet today. Imagine connecting through broadband to your AOC or service provider, streaming information that's available in the aircraft today. Those things will create a whole set of new services and capabilities for the airlines to actually be monitoring the health of the aircraft, to actually push things up to the pilots to help them guide them through potential issues that they may be out in front of them that they haven't seen yet. It'll provide a whole host of different flight and flow capabilities for service providers to provide. So again, I think this whole notion of an integrated cockpit and information flowing in a very highly sophisticated way will unleash businesses like we've never seen before. So how do we get there? Some kind of lessons learned. It all starts with some clear vision for all of us, some clear set of principles about how we want to move forward, and some kind of I call it a functional architecture, but a functional architecture, simply put, is a notion of what are the core areas that we need to focus on when we move forward. I think about the early next-gen days, we had a clear vision. We knew the core things that we wanted to do, and we called out a few core areas that we wanted to focus on as a set of stakeholders to move forward. And they were things like, hey, we want to move from ground-based navigation to space-based navigation. That's what I mean by a high-level functional architecture. Let's all focus on accomplishing a core set of things. The other thing that I think it takes is this whole notion of a well-orchestrated collaboration between government and industry. We heard Wayne earlier. We're here at an RTCA symposium. We know how to do this. Okay, we all know how to collaborate with one another. It's just we need to focus on certain core areas that will allow us to get to the future. I think about some of the successes in the past, and it's the reason that I think we want to continue to repeat these things. Successes like RTCA Task Force 5 that help prioritize the set of investments and capabilities that we needed to enable the future for NextGen. Or the NAC, the Next Gen Advisory Committee that's focused on prioritizing things for the Northeast Corridor. These are public and private collaborations that set us in a common direction to go forward. These kinds of consensus building things are hard, but they're critical. And when I talk about, think about what does it take to successfully build consensus on any of these new things, I think about kind of answering three sets of questions. I think about answering the question of when you're trying to move something forward, what is it? Why should I care? And why should I believe you? And if you can answer those three questions properly, what is it? Why should I care? And why should I believe you? You move the industry forward. And to help us answer the what is it, it's typically through our sets of laboratories that we all have. You got to see it. When you talk about what is it, we saw examples of Wayne's examples that he showed about launching aircraft and the interaction with the system. So you have to see it. You have to see what the operation looks like to answer what is it. That's typically through laboratories. This notion of why should I care, that's typically fast time modeling and simulation. And it answers the questions around cost, benefit, and risk. Why should I care to move to this new operation? And the last thing is, why should I believe you? And the whole notion of why should I believe you, it's this rich data and information that feeds the fast time modeling and simulation or feeds the laboratory environment. Okay, this is how I've seen successful consensus building happen over the future. So I want to kind of circle back to maybe some comments I made in the beginning around the current situation in COVID-19. I didn't know, but none of us knew we would be here, basically. And I watched this industry, whether it's the FAA or airlines or whoever it is, the OEMs, how they're responding to these things. It's incredible. And it's that flexibility. It's the camaraderie of our industry. It's us working together that is going to move us forward. I'm so surprised by all the different news articles I see. I saw one a couple of weeks ago that said Anchorage, Alaska was the busiest airport in the world. Who would have dreamed of that? Okay. This is spectacular stuff that we wouldn't have dreamed of, but it's happening, and we're going to be a better industry and set of organizations because of it. I thought maybe I would end where I heard Wayne, and he said the future's bright. I absolutely believe the future's bright. I think working together through organizations like RTCA and others to collaborate, to focus on a set of futures will enable us well over the next 15 years. Thanks very much for listening to me. And Terry, I'm going to turn it back to you.
Thanks, Gregg. As I expected, very thought-provoking and great information. Well, that concludes today's webinar. Again, my sincere appreciation to Wayne Monteith and Gregg Leone for your valuable participation today. Also, again, congratulations to Dr. Reed on his selection as the recipient of the William E. Jackson Award for 2020. And again, I want to thank our sponsors for today's webinar, Collins Aerospace, National Business Aviation Association, American Airlines, the Aircraft Owners and Pilots Association, and the MITRE Corporation, and the Airline Pilots Association International. For the audience, thank you for taking time out of your busy schedules to join us. As Al mentioned early, this session has been recorded and will be available for review. I think we're all going to want to go back and listen to some of the things that both Wayne and Gregg had to say, just to refresh our memories a bit. But I do hope that you found your time well spent, that you found today's presentations both educational, inspiring, and perhaps even evolving. Please join us again next month on July 15th at 1:00 p.m., same time. Our featured speaker is going to be the Honorable Robert Sumwalt, Chairman of the National Transportation Safety Board, and it will include a tech talk from Mr. Pete Bunce, the President and CEO of GAMA, the General Aviation Manufacturers Association. Thank you again, and have a